Welcome to the Day 5 notes for 6 inverse matrices and systems of equations. Today we're going to find the inverse of a matrix using a calculator, and we're also going to solve systems of equations using matrix equations. So the first thing we need to talk about today is the identity matrix. And what that is it's a square matrix that, when multiplied by another matrix equals that same matrix. So it's kind of like in multiplication. If you multiply a number by 1, you're not changing that number. 7 times 1 is still 7. That's the identity of multiplication. Or in addition, 0. You could add 0 to anything and not change its identity. The identity matrix is used in matrices. You could take it, multiply it by a matrix. You're going to get that exact same matrix. You're not going to change its elements whatsoever. So a 2 by 2 identity matrix is, like we said, it has to be square, and this one's 2 by 2. It has a 1, then a 0 is its first row, 0, and then a 1 is its second row. So this is called the main diagonal. Those elements are both 1s. 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, the way that you're going to be able to tell that two matrices are inverses of each other is if their product, so when you multiply them together, their product is the identity matrix. All right, so if you're ever questioning whether two matrices are inverses, you would just multiply them together in both directions and see if you get the identity. If matrix A has an inverse symbolized by a to the negative 1, then A times a to the negative 1 will equal the identity matrix, which up here we're showing that the identity matrix is always capital I, and if I reverse that order of multiplication, a to the negative 1 times a, you will also get I. Because remember, with matrices, the product AB is not always the same thing as the product BA, so the order in which you multiply is important. From here on out, you're going to need your calculator to do all the problems, so please, if you don't have it on you, go get it right now. Alright, so we're going to determine whether these matrices are inverses. So we're given two matrices, they're both 2 by 2 matrices. We're going to enter each one separately into our calculator. So again, enter matrix A, which is X, and then enter matrix B, which is Y. Alright, once you have them in your calculator, we are ready to check if they're inverses or not. So if they are, the important thing here is that if you take A times B, it's going to equal B times A, which is equal to the identity matrix. So to check that, you're going to press second x negative 1. So you already have your matrices hopefully entered, and choose the first matrix. Then press second x to the negative 1 and choose matrix B, then press enter. So you don't even have to multiply, put the multiplication sign in between. If you do, it's okay. And when you do that, your screen will look like this. So the answer you get is a 2 by 2 identity matrix. Now we're going to check the reverse order of multiplication. So you're going to choose matrix B, then matrix A, multiply them together, and you get the identity matrix. So you should notice that when we get A times B, it equals the same thing as B times A equals, which is the identity matrix. So therefore, we could say that they are inverses of one another. Now, if I was to do A times B right here, and I get something totally different, like if I got 4, 6, 7, 8, okay, some random numbers that aren't the identity, you could be done, because there's no chance that they're going to be inverses. But if you get that A times B is the identity, you do have to check if B times A is, because that could be some other random matrix, in which case then you know that they're not inverses. I would like you to do example 2 on your own. You're given two matrices again, and you're going to determine whether they are inverses. So please pause your video and try this example on your own. Hopefully you got the identity matrix no matter what order you multiply them in, so then we know that they are inverses because PQ, that product, equals QP, which is equal to the identity. Second part of today's notes is finding an inverse. Not every matrix has an inverse, and we're going to use our calculators to see if it does or not. If a matrix does have an inverse, that inverse will show up on your screen. If it doesn't, you will get an error message, in which case you know, okay, that matrix has no inverse. So let's put this matrix into our calculator. Now here it's called B, but I always just enter, if I'm starting over a new problem, I always just put it in the first slot for matrices. So I'm going to call it A, and I put it in. Now I want to go back to my home screen, choose matrix A. So at first you're just going to have this little matrix on your screen. You have to get this -1 there, and the way you do that is you press the X to the -1 button. And I apologize because my calculator here somehow reflected. It's the mirror image of what it should be, but we know where X to the -1 is because we use it all the time to enter matrices. So on screen you will get this 2x2 matrix, and I personally don't like decimals. I always convert back to fractions. So hopefully at this point you know how to change a decimal into a fraction on your calculator. You hit math, and then the first thing is frac, so that's changing into a fraction. So you hit math, enter, enter, and you'll get the inverse, which is -1, 0, -4, -1/2. Now of course if you know that -0.5 is -1/2, you don't have to hit the math frac button, you would just convert it yourself. Okay, example 4 then, I would like you to try on your own. We're going to find the inverse of the matrix if it exists. So F is 4, 6, 6, and 9. Please pause the video and try this problem on your own. So this is the answer that you should have come up with on your own. So up till now we've learned two things: determining if two matrices are inverses, and the way we do that, we enter each one into our calculator, find their product in both directions, and if we get the identity both times, then they are inverses. And then the second thing we did was we found the inverse of a matrix using our calculator, input the matrix, raise it to the negative first by pressing the X to the -1 button, and if something shows up on screen, that's the inverse. If you get an error, there is no inverse. The last part of this lesson is systems of equations, and matrices can be used to solve systems of equations, which gets really nice, especially if they're messy answers. And the way that works is the first thing you want to do is you're going to write yourself a matrix equation. So you're going to do matrix A times matrix X, and this is going to equal matrix B. Matrix A is your matrix of coefficients. The numbers in front of the variables. Matrix X is your matrix of variables. And matrix B is your constant matrix. So now remember, our goal when solving a system is to find what X and Y is. So we want to solve for this matrix right here. We want to solve for matrix X. So I'm going to write this out over to the side here. Basically, we have A times X equals B. What we want to do, we want to get X by itself. So I would have to go and multiply. I have to get rid of that A. I want A to go away. And the way I would do that is to take and multiply A inverse times A. And then we have X equals, but I can't do something to one side of an equation without doing it to the other side. And the order on the right side here is important because, again, matrix multiplication, order does matter. So I'm going to do A inverse times B. A inverse has to be on the left of B because I did it to the left of A. So in the beginning, we talked about the identity matrix. And if you take a matrix and you multiply it by its inverse, you get the identity. So we would have at this point the identity times X equals A inverse times B. And the first definition I told you is that the identity matrix is one that if you multiply it by a matrix, you're not going to change that matrix. So what you end up with is X equals A inverse B. So now I'm going to show you how this applies to systems of equations. So let's take this first one. We are going to write a matrix equation. It's going to be this. However, I'm going to have numbers and variables in there. So again, matrix A is AX equals B. So I'm going to take this system and write it as a matrix equation. So matrix A is my matrix of coefficients. So -1 and 1, those are the coefficients of the first equation. And then -2, +1 are the coefficients of my second equation. So I'm getting those numbers from here and from here, the coefficients of each equation. The second matrix is your matrix of variables. We only have two here, so we're going to write x, y. This matrix is always a column matrix. It always goes up and down. If we had three variables, so a 3x3 system, we would write x, y, z going up and down. Now this is going to equal your matrix of constants. These are your constants, so 3 and 6. All right, since all of this solving is going to be done using your calculator, you are expected to show what I've shown so far, and then you're going to say this equation right here, we are eventually going to multiply both sides by the inverse of A. You're going to end up with x equals A inverse times B. You do have to show that. So in your calculator, you will type in these two matrices, A and B, put them into your calculator, and then actually do this on your screen. A, raise it to the negative first, and then times B. What you'll get is a matrix. Your answer will be a matrix, and in this case, that matrix is -3, 0. Okay, so then you want to write that because this is a system, and the system is an ordered pair. If it does have a solution, it's at a point. You want to write -3, 0. I'm going to make it very clear what you need to show on a piece of paper, because that's usually the part that kids struggle with. What do we need to show? The first thing you need to show is your matrix equation. Take that system and write it as a matrix equation. Second, show how you're going to get x, that variable matrix, alone. So you're always going to write x equals A inverse B. The third thing you want to show is the matrix that shows up on screen, so the answer expresses a matrix. And then finally, because this is a system of equations, we want to write the answer as an ordered pair. All right, let's do B. So again, step 1, write it as a matrix equation. 3, 1, 5, 3. Those are my coefficients. That's my first matrix. That's matrix A. Second matrix is my matrix of variables. So I only have two here, x, y. And finally, my matrix of constants, what the equations equal over here. So that's the first thing I want to show. Enter A, again, the first matrix being A, the matrix of constants being B. Enter those into your calculator and then say, okay, the way I'm going to get x by itself is A inverse B. You will actually press that on your calculator. You're going to get matrix x, which is equal to, and you will get decimals. So again, you want to convert those to fractions. It's 3/4, 3/4. And the last and final step to this is write that as an ordered pair. So the top number, I should have mentioned, because this is matrix, x and y. When you get your answer, the first element is your x, the second element is your y. So the solution to this system is 3/4, 3/4. If at any point when you're solving a system, if you're not sure if the answer is correct or not, don't forget you could always plug in the numbers that you get for x and y back into the original equations and see if it equals out, and then check in the second equation as well. And if it does, then you know that you did the system correctly or solved it correctly. Okay, so now part C, I would like you guys to try on your own. Don't forget to show the 4 things that you have to show to get full credit on homework and on any assessment. Pause the video, please try it. Okay, so here's the solution. I didn't show every step, obviously, but you needed to. And if you're not sure, remember you could always plug it back in. Make sure that that answer does check out in the original system of equations. I want you to recall that when we do systems, when we were doing them in Chapter 3, graphing them or algebraically, we didn't always get a point of intersection. We didn't always get one solution to a system. When you do get one solution, that does mean that you have 2 lines and they intersect somewhere. And that somewhere is what we're looking for. That's that ordered pair. But remember, it could be that you have two lines, and when you graph them, they're parallel. That would be no solution. Or when you solve them algebraically, you get no solution. And then the last thing that can happen is it's the same line, where there's infinitely many. All points on that line are solutions. Unfortunately, with this method, if it is one of the two special cases, and I refer to these two as the special cases where there isn't a solution that is an ordered pair, it's either no solution or all the numbers on that line, all ordered pairs on that line, this method gives you no way of knowing that except for the fact that you're going to get an error message. But as far as being able to tell which case it is, no solution or infinitely many, you can't look at the calculator and be able to tell. You are going to have to then go and by hand solve that system, either using substitution or linear combination, aka elimination. So just to make sure we're clear, if you do get an error message using inverses to solve a system, that does mean it's either a no solution or an infinitely many, and you're going to have to refer back to substitution or linear combination to tell which one it is. Okay, so that is all for today. I hope that you have a nice break, are having a nice break, or had a nice break, depending on when you watch this, and we'll see you next year. Bye.